So we are ready to go with a global similarity. So for a global similarity is a build up of the local similarity. So where it can be calculated based on this equation, where the similarity between a new case which is A and the old case which is B is equal to 1 divided by the summation of the weight of the attributes and then multiplying by the weighted sum of the local similarity, meaning that the summation of the weight for attribute I multiplying by the local similarity for I attributes. So now let us see how we are going to calculate the global similarity between the new case and case 1 by using this formula. So first of all, you have to ask here, what is the weight for the attributes? If we be back to the questions here, the experts say that the attributes of Bahang and Bitcan are the most important as stated in the question. The experts said the second attribute, which is Bahang, and the fourth attributes are the most important comparing to other attributes. And since these two attributes are most important, the experts suggest that the value of this attribute will have a twice value of the other attribute. So meaning that if we put the weights for Bahang and Bitcan value of 2, the other value should have 1, right? So that's why we are going to assign the value of these two attributes with the twice value of others attributes. So I'm going to add here beside this to add the weights. So weight which attribute. So firstly, the weight for the first attribute, which is a dam. So first of all, let me assign for the most important. So for example, Bahang is the most important attribute, right? So I'm going to highlight it with a 2, while Bitcan is highlighted also as one of the most attributes, so 2. Other attributes will be assigned with 1. Why 1? Because as stated in the question, only Bahang and Bitcan should have a twice value of other attributes because they are important. So now this is the attributes. So I'm going to highlight it with this color. So now I'm going to calculate the global similarity between the new case and the old case, which is case 1. So global similarity here, based on this formula, same is equal to a new A is the new case, right? A new case, we are representing a new case as a NS. So NS between the NS a new case with the old case, which is case 1, C1, right? Representing as a C1 is equal to 1 divided by the summation of the weight. So I'm going to do brackets here, summation of the weights. How many weights do we have? We have 5 attributes, right? 1, 2, 3, 4, 5. Each of these attributes have their own weights, right? So I'm going to write W1 plus W2 is the weight, right? The weights for attribute 3 and attribute 4 and attribute 5. Then, so I'm going to do a brackets here. So firstly, we get the summation. Multiplying by the weighted sum of the local similarity. I can express this as new brackets for the summation, then So meaning that I'm going to multiply the weight for the attribute I with the local similarity of the I that I have already calculated. So here, firstly, I'm going to use weight 1 for the weight 1, right? So W1 multiplying by LS1, right? LS1, sorry, LS1, that is highlighted with blue color. LS1 meaning that the local similarity degree for the first attribute, which is a dam water level, then plus with 2 multiplying by LS2, right? Then close bracket, LS2, so it is the one that is highlighted in the blue color. Then plus LS weighted average for attribute 3 with the LS for third attribute. Then plus weight for the fourth attribute multiplying by the LS for third attribute. Then plus the weight of the fifth attribute multiplying by LS for the fifth attribute. So this is how this formula can be expressed, but I have to close the brackets here for the bigger. So this is how, where we do have here, if you look, 1 meaning that the summation of multiplying the weight of the attribute I multiplying by the local similarity of I attribute, where we multiply the weight of the attribute of the first attribute with its local similarity, and second attribute, the weight of the second attribute multiplying with local similarity for the second attribute, right? LS2, and the third and the fourth and the fifth. We have to do that for all attributes, since in this our case study we have only 5 attributes, 1 2 3 4 5, right? Same as the new case, 1 2 3 4 5. So now let us see how we are going to execute this. So 1 divided by summation of the weights, right? So here, what is the value of W1? Is a 1. W1 meaning this one. The value for the first attribute, which is dam water, have a value of 1. So I'm going to take 1. So 1 plus the value for W2 is bahang, right? The weight of the bahang is 2. So 1 for the third attribute, which is a W3, the weight of the third attribute is 1 plus the W4 is 2. 2 plus, right? W5 is represented here as a 1, right? So 1. Then multiplying by weight 1 is 1, right? W1, the weight for attribute for the first attribute, which is dam water, is a 1. Multiplying by LS1, a local similarity for the first attribute, which is a dam water level, right, of the new case, and the dam water level of the old case, which is case 1, which is, let me delete this one, which is 0.904. Then plus W2 is 2 because it is the weight for the second attribute, which is behind, right? So 2. Then multiplying by LS2, which is the local similarity of the behind attributes value of the new case and the behind attribute value of the old case, which is a case 1, right? Same goes for all attributes. Plus W3, weight 3 is this one, 1, right? The weights for the third attribute, sorry, is 1, and LS3 is here, this one, right? LS3 value is calculated is here, right? So I'm going to take this one. Then plus this one, the fourth attribute for W4 is 2, right? Where the LS3, oh sorry, here it should be LS4. Sorry. So here should be LS4 because the log for the attribute for the fourth attribute, right? 4 is equal to 0.49, right? So here 0.49 plus the weight for the fifth attribute, which is 1 gambang, right? So 1 multiplying by LS5, which is the local similarity degree between gambang attribute value of the new case with the gambang attribute value of the old case with C1. So here is, after you do this calculation by using the calculator, you will find the similarity with 0.467. So this is the global similarity, meaning that the new case is a similar C1 with a similarity degree of 0.467. So now we have calculated the local similarity and a global similarity, and we have, from that we know that this is the similarity degree between the new case and the old case C1, right? So now we have to repeat the calculation of a local similarity and global similarity between the new case with the other old cases. I'm not going to do, you are going to do that with repeating the same process. So you can pause this video and do for the new case with the second case, for the new case with the third case, for the new case with the fourth case. So here is the result of calculating the local similarity and the global similarity between the new case and the case 2, case 3, and case 4. You can check your answer with me here. We have identified that the new case is similar to the second case with a similarity degree of 0.563. For the case 3, we have find that new case is similar with, for the case 3, after we calculate the local and the global similarity, it has been found that the new case is similar to the case 3 where the degree of a similarity of 0.858, and here for the fourth case where we have found the new case is similar to the fourth case with a similarity degree of 0.241. After we execute the similarity measure between the new case and all old cases, we can conclude that we will write here the outcome. The new case is similar to the case 1 with the value of this one. And the new case is similar this one to the case 1, right? This one to the case 2 with a value of 0.563. Also, the new case is similar to the case 3 with the value of this one. I'm just copy to confirm that it's right. 0.4. And the new case is similar to the fourth case. The value of what? Here it is, right? The result of the global similarity between the new case and the case 4 is 0.4. Based on this outcome from the result where we calculate the similarity measure, so from here, which one do you think is the most similar case to the new case? You have to remember, my dear mates, the highest similarity degree is representing the more to being similar to the new case, meaning that here the highest value here is 0.858, right? Meaning that case 3 is the most similar case to the new case. So this is the outcome. I will write it here. Case 3 is the most similar case to the new case, right? So now, by having this outcome where the case 3 is found to be the most similar case to the new case, so now we will go to the second cycle of CBR, which is reuse, where in reuse we have already got case 3 is the most similar case to the new case from the case base. So now in the reuse case, we are going to reuse the solution of case 3 that is identified as the most similar cases. So here we can find this is the case 3, right? From here, I just copy from here. This is the case 3, right? So where is the solution of the case 3? You still remember the gates, right? Here, this is the part of the solution. And this is the parts of specification, the attributes, right? So we are going to, in the reuse, we are going to reuse the solution here. So the solution of the gate of the case 3 is, so in the reuse, how we are going to reuse? We have 3 options. Do you still remember in our slides? We have a modifications, we have adaptations, where we do the adaptation by the user, or we use the automatic adaptation solution. In this case, we will go with the first option, where we just only going to copy. Why? Because our solution in this case study is have only 2 possibilities, open or closed. So we cannot adjust. That's why the proposed solution, which is reduced from the reused or suggested solution, is closed by just on copy the solution of the retrieved case, which is case number 3, right? Then the proposed solution or suggested solution, which is closed, is going to be shifted to the revised cycle. In the revised cycle, here, this is the revised cycle. So in our example, in executing the revised cycle will receive the proposed solution or the proposed decision that come from the reuse, which is a close, right? However, in executing the revised cycle for our case study, we are going to the first option here, which is no revise phase, meaning that no revision is needed here, meaning that we are not going to revise this solution. Why? Because in our case study, the solution can only limited to two values, open or close. So if the extracted solution, the suggested solution is closed, so we keep it as it is closed. So then the revised cycle will remain solution as a close, and this closed solution will be named as a confirmed solution. Then this confirmed solution will go to the retain phase. How we are going to execute the retain phase? Here it is. In the retain phase, we are going to store the new case with its solution in the case space. How? You can see here where I have added already the new case. This is the new case, right? With its solution is close, right? To the case base. So this is the old case base that we got in the beginning of our case study, right? But here, if you look, we have updated the case base by adding the new case with its solution. This is the new case where we documented with the number 5, and the dam water value attributes will have the same attribute here as this one, because this is the new case. So I'm going to add the specification set, which is the set of attribute as it is. 2 for Bahang, 20 for soy, Bikan 22, Gambang 20, so it will be 20, and the confirmed solution, which is close, that we get, right? This is how we store the new case in the case base. So this is the end of our case study, where quantum departments of irrigations will know that the solution for the new case is close, meaning that they have to close the gates. So that's it, and I hope that it is clear, where I have tried my best in order to make it clear for you. If you do have any questions, you can ask in the lecture sessions. And thank you very much, and I wish you the best of luck.